Second day to review for the check-in. Wanted to go over a couple things from the homework from yesterday. So we got width of rectangular classroom is 20 feet, perimeter of the classroom is 84 feet. What is the area of the classroom? So first thing we have to do is find the other side of our rectangle. When we have a rectangle, the perimeter is adding up all the sides, right? So if it says the width is 20 feet, we got width of 20 feet. If perimeter is adding up all the sides, and we know the perimeter is 84, basically we're working backwards to find that other side. So instead of adding, when we work backwards, we're going to do opposite. We subtract the two widths. That'll give us 44. But we have a length and a length. We've got two lengths. That's a step I saw a few people forgetting yesterday. Since we got two lengths, we need to divide that by 2. What that means is each individual length is 22. Okay? Then it asks for area. So we got 20 times 22, and that should be 440. Okay? Any questions on that one? Some of y'all did pretty well with it. Some of y'all, like I said, were making a few mistakes. Definitely in the other classes as well. Just want to make sure to get one of those. All right, other thing we did yesterday was problems like these. The AI program I used for a couple of them kind of screwed them up, but so I wanted to do one that I know works. Least common multiple of two numbers is 60. The greatest common factor is 4. If one of the numbers is 12, what is the other number? All right, so what this means is if we're finding the least common multiple, we've got 12 and something else, and it's going to equal 60. Same idea with our greatest common factor. We got 12 and something else. It's going to equal 4. So 4 has to go into that number, right? So if I make a list with my 4s, 4, 8, 12, 16, 20, 24, 28. We don't even really have to list all of them. We can just go a little ways usually, and that's probably going to be far enough. But we also need something that goes into 60. I could also have 60 on this list if I kept going, so 60 would be one of the possibilities. All right, does 4 go into 60? Yes, no? You can always check with division. 60 divided by 4, 15. So 4 would be a possibility. If I do the least common multiple, though, of 12 and 4, that's not 60. Least common multiple of 12 and 4 would be 12. So that doesn't work. 8 does not go into 60. 8 doesn't work. 12 goes into 60, but 12's already the other number, so 12 doesn't work. 16. 16 does not go into 60. So 16 doesn't work. So now we got 20. See how I'm just going down the list, right? I'm eliminating the ones that don't go into the least common multiple there. So if we try 20, what's the least common multiple of 12 and 20? 60. So then we try the greatest common factor. Greatest common factor, 4. Hey, there's the answer then. Okay? There's a little bit of math to it, a little bit of kind of using process of elimination. A little trial and error, right? If you list out the factors, a lot of times that makes it a little bit easier to know which numbers to use. If we did the factors of 60, you're looking for the ones that are on both lists also, and that can help you narrow it down too. Any questions? All right, we need the surface area of that cube, side lengths of 5. Go ahead and try that one. I can pretty much 100% guarantee you will see a cube. Sarah E? Nope. Sydney? You find the area of one of the squares first. So if side length's 5, that means base and height, length and width, both are 5. So we got 25. 5 times 5. Then there's 6 squares. So basically what we got is 5 times 5 times 6, which is 150. Okay? You left off one of the 5s. We get the area of one square, and then we can multiply it by 6. If you really wanted, we got 6 squares. You could add them all up too. If you're not so good at multiplying, and you got to do that with the inactive part, you could add up all these 25s also. All right, find the surface area on that rectangular prism. Jeremiah? Nope. Robert? 158 is correct. All right, when you have a rectangular prism, again, pretty sure you're going to have at least one on your check-in. You make pairs. Remember we did it with the 3 people kind of introducing themselves, right? That's what we want to do here. We're making 3 pairs with multiplication. So we got 8 times 5, 8 times 3, 5 times 3. Each number was used twice. I used the 8 twice, the 5 twice, 3 twice. And none of the pairs are the same. Only time pairs would be the same is if 2 of the numbers were the same. So 8 times 5 is 40, 8 times 3, 24, 5 times 3, 15. We add them up. That's where the 79 comes from. But what those 3 pairs do are they take care of 3 of our rectangles. We got 6 rectangles though, right? If you remember, I said when it's a box, you got a front and a back, top, bottom, left, right? So we multiply that by 2, and that's where the 158 comes from. Okay? The 2 most common mistakes I see with this one are, well, like we did, we forget the multiplying by 2. The other thing I see people do is get the volume, just multiply the 3 numbers together. But you want to make pairs. Okay? Any questions? All right, this is about as hard as a parallelogram can get. I suppose I could have the diagonal side, and that would make it a little tougher. Judah? 72. How do you find area of a parallelogram? Base times height. What's the base? 12. Base is the whole thing, right? So we got to add the 4 and the 8. The height has to be perpendicular, has to make a right angle. That's the height. I didn't, but if I did give you that diagonal, remember we don't use the diagonal sides, okay? So we got 12 times 6. That's 72, like she said. Good on that one? I mean, parallelogram you can't make too tricky, really. Same with a triangle, not a whole lot you can do on this one. So go ahead and find the area of that triangle. Jacob? 100's correct. Base times height divided by 2, right? What's the base? 20. What's the height? So we got 20 times 10 divided by 2, and like he said, that is a 100. Okay? extra numbers, most likely the way that a triangle looks tricky. This one looks a little tricky as well at times, so give that one a try. Kyle? Nope. Try? Nope. Mason? Kyle, you forgot to divide by 2. All right, so we got base times height divided by 2. What's the base? 8. The base and height have to make a 90-degree angle. That's the base and the height. Why did I not highlight the 2? Yeah, it's not actually part of the triangle. Sometimes, like with our parallelogram back here, you have it where it's part of the shape. That's when you got to add it up. When it's not part of the actual shape, you don't add it up, but these 2 lines would still make a 90-degree angle. That's what the dotted line is for, to show where it makes that 90-degree angle. So we got 8 times 9 divided by 2. That gives us 36. Okay? Trapezoid. About as tricky as I could make that one. Ford?
72.
Nope. Lacey? 120 is correct. We add the bases. All right. What's my base on top? 12. Yeah, we better get that one right. Base on top's 12. What's the base on the bottom? 18. 18. Base is all the way across, right? The 3s are just those edges. It's a rectangle in the middle, so what that means is we got 12 up there. We also got 12 down there. So the whole base is 18. So we got 12 plus 18. Got to do that first. 12 plus 18 is 30. Once you add the bases, you can multiply by the height, divide by 2. Order on that part doesn't matter. Calculator can do it all at once, but you got to do the adding first. Adding has to be done separate. All right, and then once you do that, you get 120. Any questions? I'll tell you what, try this one first. A little tougher. Rectangular dog park has a length of 20 meters and a width of 15 meters. They're building a 3-meter wide walking path around the park. What is the area of the path? I have seen problems similar to this in 6th grade, 7th grade, and 8th grade. 8th grade math typically includes variables with it. So good chance you see something like this at some point. Ford?
100.
Nope. Sarah E.
900.
Nope. Lacey? 1146. All right, everybody's good with that part, right? We got the park in the middle. We got the path going around it. That's how the picture would at least kind of look, right? So what we want to do, it's a shape inside of a shape. You do big area minus little area. The little area is the actual park. We got 20 by 15. Okay? So 20 times 15, that gives us 300 on the actual dog park. That part so far, that's not bad, right? All right, so the tricky part then is getting the path, getting our big rectangle. How wide is the path? 3. What that means is right here is 3, right? Same with right here, isn't it? That's also 3. So how far is that? Well, if I stopped at the corner. 26. 3, 20, and 3. Everybody go with 26? Yeah? All right, so we do the same thing for the height or for the width. That's 3, right? That's 3, so that makes the whole thing 21. 3, 15, 3. So we got 26 times 21. That gives us 546. And shape inside a shape is a subtraction problem, so we subtract the park itself. And that gives us 246. Okay? The most common mistake I usually see on that is people just add 3 only to each number. Instead of saying 26 as the big area, they say 23 because the path was 3 wide. But you got the path on each side, right? Any questions on that? Out of 6th grade stuff I've seen, that's probably one of the tougher type problems. So, I mean, if you can follow with that, you can probably do just about any of the problems. For our work today, we're going to do some of those, we're going to do some of those where you got to drag and drop and